Welcome. This video is about processing of hyperspectral data over terrain. And first of all, we need to check out our data. So it is the image, and this is the one we're gonna look at. That's the that one, and it's a geo-corrected image from hyperspectral Mionia data with about 300 bands or 400 bands, exactly 491. And together with that, we need a DEM now. And the DEM has to be imported and prepared such that we can do a terrain correction for this imagery. So how to import the DEM? We can do a DEM preparation for that. So we can just check the raw DEM, and we select the input image, and maybe we take a diameter of about 5. So this means in this case 0.5 meters smoothing for the side layers. And maybe we're gonna write a SkyView file, but it's not as necessary here. Let's define the output. This should be a file named _ele, because atcor likes the default names for its processing, so it's easier afterwards if you name it always with _ele. Okay, so now we can run it, and it will overwrite it because I already did it before, and it's calculating the sky view factor, so the portion of the visible sky. And now we can check out if this looks as it should be. So we look at the env file, which is the ele. The ele itself doesn't look very interesting, but if you look at the slope or the aspect file, you will see if there are any artifacts. So let's see how the slope looks like. Display env file, we take the slope now, and the slope is created automatically together with the ele file whenever you do a preparation. So that's this one. And now in the slope file, you see there are quite some steps in there. These steps may result in artifacts afterwards in the processing, and maybe we don't want to have that much artifacts in there. So that's why it's recommendable to smooth the DEM before doing the processing. So we make a DEM smoothing. I'll take the original DEM. I smooth by a factor of 5, so to 0.5 meters, and I'll smooth it to a new name. Just name it smooth 5, SM5, and this will be my new input DEM afterwards. So this is smoothing now and is stored directly. So if now we can repeat the step of before. We do a DEM preparation now with the smooth DEM on the basis of the image itself, and maybe we take a larger diameter for the processing. I'll take about 11, 9 is okay, and I'll rename it the smoothed output. So smooth 5, and I'll put it in the same direction as the image is because it's easier to select afterwards. So I'll take that one. I think it's already there somewhere. Yeah, here it is. So I'm gonna overwrite the existing one, and it will just create the correct elevation file. So now we got all the layers available. I can check again the smoothed slope file. Where is it, the smooth slope? And see how it looks like. Now this looks much better than before, so not that many artifacts left. This seems to be suitable for MSI correction. So as we have prepared this, we can go further into the atmospheric correction. First one wants to create the in file. So I'll go to the import function and import from a part status and select the status of the maybe the sphere status. Acquisition time is missing, but acquisition time can be found usually in the image itself. So I'm going to select the image and let's see if this works as it should. So here is the image I want to correct, and now it found some acquisition time and it can let's select that one again, and it can calculate the azimuths correctly from these two files. The elevation model, I can select now the smoothed elevation model, that one. And the sensor is this dual 491. So it has been processed to 491 bands in total. That's something I don't go into now as of how to define the sensor. That's something which is shown in a different video. So now everything is prepared. I can write the in file and I'm going to overwrite the existing one, and now it should be ready for processing. The in file contains all the parameters, including the information about the elevation model. So let's go into the processing. I go to the rock terrain atcor now, and the rock terrain atcor asks for the elevation model first. I'll take the smoothed one. Everything is found, so seems to be correct. It also finds a scan angle file, and it has, let's check the geometric parameters. This looks all right. It has the sensor defined. I'll want to select the atmosphere. In this case, it has been shown that it's better to use the 10 centimeters water vapor, because it's low altitude. We can't do the image-based water vapor retrieval. Adjacency effect 0.3 is fine. Visibility is maybe a little bit higher. That's just something which doesn't have a big impact on the results, but that's numbers which can be found for this very clear data acquisition. So first we can do a spectra, as the scan angle file doesn't seem to be correct. Ah, yeah, it's the wrong one. That one is the correct one. So let's see if this is still correct. Yeah. So the scan angle file is now the one corresponding to the image, and we can do the spectra check. It does some water vapor retrieval here. So afterwards we'll do it without, but we'll see how it looks like. It takes a while to calculate the water vapor LUTs, and then we can